Ladies and gentlemen, I've just always wanted to do that. Okay, today we are going to do the keyGme, crack me, that I threatened to do a couple of weeks ago. Life has gotten in the way. I apologize for the delay of that. But we are going to use keyGme. We're going to write a keygen for that using Python. That seemed to be a really popular thing from the last video, and unfortunately I didn't film it to where the code could be read very well. So I have keyGme here. I will put a link directly to the crack me on crackmes.1. If you cannot get this to run, it's because it's a 32-bit app, and on a 64-bit OS, it causes a few problems. You got to install a couple of packages. I'll also put those commands down at the bottom. So if it gives you an error like file or directory does not exist, that's why. Go ahead and run the commands that I put in there. It'll install some of the packages, and then it'll be able to run that 32-bit app. We're going to do all of this in Ghidra today, and we're going to move relatively quickly because there's a lot of ground to cover between the reverse engineering and the writing the code for the keygen. So let's get started. Let's run this bad boy. Let's see if we put no parameters, what happens. Okay, it's asking for that plus a serial key. Let's go ahead and do that. Okay, key must be 16 characters. That's great. And let me see here. That's 4, 5, 8, 12, 16. Okay, now it says it found invalid character. So we've got 3 error messages there that we're looking at right away on this thing, which is great. I went to the dark theme on this. We'll see how that works. Get this bad boy imported, let it do its default thing here. And let's go ahead and get this bad boy opened and get going. Go ahead and analyze it. I just go ahead and select all analyze. And I believe that's done. Let's go ahead and filter for the main function. Here we are. Okay, right away, we can see all of the C code that was generated, which, by the way, I tried doing a little bit of this in Ghidra 2, and yeah, I am not good at assembly yet, so that's part of the delay here as well. But again, I think the keygen part, I think that's the part that people like anyway, so we'll go ahead and get that done. Okay, so right away, looking at this C code, we can see, sorry, the code was invalid, which, if you remember, that was the, no, we didn't get that error message. Congratulations, you are registered. Code was invalid. So this was one that we never actually made it to. Key must be 16 characters. Okay, well, right here, we've got a string length that we're looking for. And we're saying if the string length is equal to 16, I believe 0x10 is 16. I've got a Python shell open here, so 0x10, yep, that is 16. So right here is where it is checking to see if it is 16 characters in length. Okay, so if it is, we're going to go ahead and check out this function right here. So you can double click that function. And here we go. We're off in another function. Here we go. Found invalid character. So that's the one that we hit when we did test, 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 test. Okay. So in looking at this, we know that we have to have 16 characters. Let's go ahead and start out. Let's open up Visual Studio Code. And let's go ahead and create the Python file here. We're going to call it keygen.py. And we're going to just kind of put in comments for what our requirements are. So 16 characters in length. Okay, that's the first requirement. Okay, so this is saying that this looks like it is an iterator. Okay, it starts at 0. And then it's basically saying do this as long as the integer of that -1, so that's the length of parameter 1 -1, is less than or equal to local 10, which is our iterator. Then it's going to run this function right here. It's going to return this if local c is equal to the int of parameter 1 as var 1 -1. So what we can do here is do a little renaming. So if you click and hit L, it will allow you to rename the variable. So we know that this is len of key, okay, because that's the length of the key that we put in. This is going to make this make a little more sense as we're going through this. We know that this is an iterator. I usually like to call that X, but we'll just go with iterator for right now. Okay, so we are trying to run this to see if we've got an invalid character. Okay, so I'm just going to go ahead and jump down here to see where we get to on this, on the invalid character. And then down here, this looks interesting. Okay, so local c is equal to local c plus the int of the parameter of the iterator. We're going to do a binary shift and then a modulus 0xf00. So 0xf00. So modulus 3840. Okay. Plus 10. I feel like that this is kind of an important thing. And see, here we go. Iterator equals iterator plus 1. So that's where it's iterating. Okay. I feel like we should document this. Okay. So we know that this is some sort of a sum, right? Because it starts out at 0, and then it's going to add up to itself. And then it's going to become part of that, and it's going to keep summing that while this iterates. Okay, so let's rename local c to sum of letters, because it's the sum of the letters inside of the key. I don't know if letters, numbers, whatever, but so we got sum of letters equals the int of the param of that binary shift modulus plus 10. Okay. So we're going to do sum plus, man, this is really where I wish I had a little bit higher resolution. I know it's hard to see the code when I do that, so anyway. So we're going to take the int of the letter that it's on, int of current letter, and that was a binary shift to 1. Modulus, what was that number again? 3840 plus 10. Okay. That is the C code that we see there on this. But before we get to that, we've got to check for invalid characters. And we've got a couple of functions here that look like they are checking for that. So let's see what those bring us. Okay, so it's saying that if the letter is less than capital letter A or greater than capital Z, return a 0. And if we return a 0, then we're going to get down in this invalid character. So we know that characters between capital A and capital Z. And let's check out the other one. We've got this function here. Okay, now if it's less than 0 or greater than 9, then it's also going to return 0. So it's got to be between 0 and 9 as well. So nums between 0 and 9. Okay, now we've just got to figure out, we've got this whole sum thing going on. We know it's got to be between A and Z. It's got to be 16 characters in length. What role does this play right here? Let's go back and look. Okay, so what we're doing is iterating through this. So what happens whenever this is no longer true? That's where we get to here. So basically, this is returning the sum of the letters, and we're comparing that to the last letter of the key. So we're turning that into an int. So the sum of all 15, when we do all this math on it, needs to be equal to the 16th character as an ordinal, and that then would give us a valid password as long as that's between A and Z and 0 and 9. Okay, let's do that. Let's see what happens here. So final thing is 16th character has to equal sum of previous 15. Okay, all right, perfect. I think this is our parameters for building us a keygen to crack the keyGme. So let's do it. First thing we're going to do is import choice. Is it choice? Is it random? Trying to remember now. It's random. Of course it is, because you got to make a random.choice. So it's import random, and we're going to import strings. And this is because we can give ourselves the actual valid values using strings. So one way that you can do this, okay, you can say that your choices are equal to 0, 1, 2, 3, type all that out, and then go A through Z, capital letters, right? But we're not going to do that. We're going to use strings. So it equals strings dot ASCII uppercase, ASCII underscore uppercase, and string dot digits. Okay, so basically this is saying our choices are any uppercase letter and any digits. So we know that we've got this hairy math thing going on up here. Let's go ahead and figure that out. So we're going to name it CharacterSum, and it is going to be equal to the ordinal of the letter that we're on. So we got to iterate through our key, right? So for k in key, CharacterSum is the ordinal of that. That's the int of the current letter. So plus equals is plus sum plus the int of the current letter. Now we got to do the modulus shift. So we're going to do CharacterSum equals CharacterSum. I said modulus shift. It's binary shift. I'm already working ahead here. So binary shift 1, okay, which is this piece right here. Binary shift 1. Now we need to do the modulus 3840. So I wonder, can you do modulus equal 3840? We're going to try this. If not, we'll have to longhand it out, but I think we might could do that. Okay, so we've got the modulus, and then we've got to add 10. So CharacterSum plus equals 10. Perfect. So this is the math that we've got to do on the key, but we've got to get a key first, right? So in order to get the key, let's set the key as a string. Key is equal to nothing, right? It's an empty string for right now. And we need to generate 15 of the characters, do the math on them, and then figure out if that math leads to an ordinal of a character that is within our allowable choices. Okay? So while the length of key is less than 15, because we want to go all the way up to 15, key is plus equal random.choice and choices. Perfect. So basically what this is going to do is while it's less than 15 in length, it's going to keep adding, if I could type, it will keep adding all of those until it gets to 15. Okay? But once it gets to 15, then we need to run up here and do this. So let's go ahead and turn this into a couple of methods. Now we're getting into, it's getting a little more hairy. So let's call this main method the keygen. Okay. And we will scoot that over. There you go. It's all inside of that. And let's call this our key check, because this is doing math on our keygen key. Okay. Now, one thing that we didn't do that we saw earlier in there is set the CharacterSum equal to 0 to start with, right? You've got to instantiate the variable there and set it to something. So we're basically setting it to 0, and now we're going to go through, add all of these other things in. Okay. Now, once it does this iteration, then we need to know what the final letter is going to be, right? Or the final value, whatever that is. And we're going to do the character of the CharacterSum. So basically we've added all the 15, and now we're going to see that character. Now that we know what that character is, we have to make sure that it is actually an allowable letter, right? So you can't have everything allowed and then the last letter be like an underscore. That won't work. So if the final letter is in choices, then we're going to add the final letter to key. And let's go ahead and print out the key just so we've got a valid key printed out. So I love to use the dot format. I don't know. I'm weird that way. So key. Perfect. Otherwise, if the final letter isn't in our choices, so let's say it is an underscore or a lowercase letter or something like that, so it's not a valid letter, we need to start all over. So basically, we're going to call this again, reset the key to nothing, run it until it gets to 15, and then we need to call this function once it does it. So then we need to call keyCheck, right? So let's call keyCheck. And we're going to have to pass the key to it, actually. The key from here. And this is going to have to accept the key. Okay, we've covered our math. We've covered the length of the key, the valid characters. Why is it giving me strings, dot digits? Okay. Not sure why that's giving me a problem there. We're going to try to run it and see. Oh, I think it's not actually strings. I think it's string. Oops. There's only one string. There we go. Okay. So here we are. Let's run the Keygen. And you know what I didn't do? Let me see here. I didn't actually call the main method. You know, I did this the first time that I was writing the Keygen. Apparently, it's a common thing for me to do. Everybody who's awesome is going, okay, this guy's an idiot. But, okay, let's run it. Okay, we got a key here. Highlight that bad boy. And let's run our Keygen, or let's run our keyGme. So, keyGme, paste in our key. Let's see if it works. All of the characters are allowable characters, uppercase 0 through 9. Congratulations, we're registered. Well, I've told you before, I don't like doing one at a time. So, we're going to add our own little counter. While x is less than 10, run Keygen, and add 1 to x. This will give us 10 keys that we can try against our Keygen, our keyGme. So let's try one of these bad boys. And there we go. We're registered. So today we've gone through using Ghidra, reverse engineered this piece of code here. I apologize again that we're not doing this in assembly. Again, I tried this in Radare 2. I am going to continue to work on this and get better, but it had been too long since I'd given you guys a video. So I wanted to go ahead and get this out there. I will go ahead and post this code in a paste bin. I'll go ahead and clean this piece up a little bit here. Put this in a paste bin, and I'll also include that in the video description for you, so you don't have to try to type all this out. You can actually just have it. Yeah, so that's it for me today. I will continue to do some of these. I think that you guys are enjoying them. I know that I'm enjoying making them. Definitely learning a lot, so I appreciate you guys sticking with me through this. Until next time, we'll see you guys later.